Good morning, everybody. So today we are beginning the sixth semester classes. The subject is software testing. So we are starting the first class, that is Unit 1, that is introduction chapter. Yes, and introduction chapter, that is about software testing. So I am M.A. Bhagewadi, working as a selection grade lecturer in Government Polytechnic for Women, Bangalore. So we'll be starting the classes. So what are the contents in this chapter? What we're going to discuss it here. The next slide. So in this topic, we're going to discuss some of the things, that is power of software. What are the challenges in software? Yes. What are the challenges in software projects and software fiascos? So these are the things what we are going to discuss in this today's session. Yes, power of software, what are the challenges in software projects and software fiascos. So first is about power of software. What do you mean by power of software? We're going to discuss. So
Sir,
software, as we have
PPT is not
discussed.
visible, sir.
Pardon?
PPT is not visible, sir.
Screen is not visible to you? Yes, power of software. So software is playing a very important part of life in everybody's lifetime. Like as we know, computers are used in education, entertainment, transportation, banking, healthcare, and business activities. So in these applications, the software is very, very complex. Like for in education system, we use for learning purpose, for like exam purpose, for evaluation purpose, for result purpose. Like for entertainment, we are watching your movies or your programs or your what you call multimedia animations, your cartoon programs, or what you call 3D or 4D or 5D, what you call five dimensional. Like you had a movie, what is that? Dinosaur or something. We had a big, how they are made. All these through the computers there. And for transportation, yeah, airline reservation, your bus reservation system, or your railway reservation system, or any other transportation system. Like for example, you are using Uber and Ola. So it has made a life so easier. So by what do you call a click of a mouse, your bus or car will be booked to you. It will come to you and pick up and deliver to, what you call drop you a particular destination there. And in banking system, as you know, so at the click of a mouse, by sitting at home, you can transfer the money to any part of the world. But that was not possible in previously without the software. Now through your Paytm is there, or Phone Pay is there, or Google Pay, any app. See, the banking sector has become so easier. At any moment of time, at midnight, 12 o'clock, you can send the money to any part of the world. Just if you have a mobile number is sufficient. You don't need your account number. Anything is not required. Just a single mobile number will help you to transfer the money to any part of the world. So the software is playing it's a very, very powerful, what you can call it. The software is very powerful. So it is playing a very important part in everybody's life, what you can call it. Yes, to implement all these things, the software is a very complex, what you can call it. It's fine. Next. Millions of code written by 100 programmers are integrated into one package. If there is single mistake committed by one programmer, it may lead to problem. See, to your banking system or your software for a banking. So we doesn't know we are using the applications, but how many lines of codes are written there? So lots of lines, thousands or millions lines of code are written there. Yes, million lines of codes are written there. Yes, but how if there is small mistake, like for example, as I told in ATM, like you're debiting 5,000 and or you're withdrawing 5,000 and it is showing 50,000, then one small zero can make a big blunder, what you can call. A small zero can make a big blunder. So a lot of what you can lines of code have been written for this particular program there. Yes, and this software has become a part of life for everybody. It has become a lifeline of the system, what you call. So without software, we cannot live. For example, just assume 5 years before, maybe 10 years before, you could just go back to the 10 years before, there was no mobile phone at all that. But now mobile has become a part of life. Without mobile, you cannot live at all, what you can call that. Without mobile, you cannot live. It may be a smartphone, so which was not there just 5 years before. There was not a smartphone also that, but now your smartphone has replaced your computer, or replace your desktop, or you replace your laptop, what you call. So your smartphone will be doing your entire work. So with what you call smartphone, your mails, your WhatsApp, your Zoom, the meeting, we can do this all Google meeting through a mobile phone. You need not have a desktop or a laptop or a tab or nothing. Just you can have what you can call as a small, as a simple smartphone will help you to what you can have all these meetings there. So this has become a lifeline of the system there. Every year, large amount of money is spent for software development. The demand for software-driven services and product is increasing. So they what you call, they are making computerized, what you call. Everything has been computerized. You name any field, so there is a computer. You're traveling in a bus, the ticket is issued by a small printout there. So that is nothing but a database. It's application of a computer. Go to a canteen, there is a printout is there. That's nothing but a computer. So you name anything. So what you call, there is large demand of software, what you call. So we require large number of computer engineers or software engineers are required to develop this program. So there is large demand because of this. What you call Bangalore, Silicon. We call the Bangalore as a Silicon City. So there are a lot of demand for developing the computer programming there. So there are so many companies are available in Bangalore. So because after US, this is the next what you call country is the next largest producer of software engineers, what you can call that. Next, the demand for software-driven services and products is increasing. Mobile phone is a complex technology which contains 2 millions of code residing in it. See, we are using a what you can call mobile phone. How many lines of code are there? We doesn't know it. See, 2 millions of code. A small phone has got so many lines of code, but we doesn't know. But we are using all so many applications are using. Yes, we are WhatsApp, we are doing chatting, we are Instagram, we are installing there, or Twitter, we are installing. You're watching your entertainment is there, your YouTube is there. Whatever you name, any application we are able to do through the mobile phones. So a small phone having around 2 millions of code inside it. The complexity of software is increasing day by day as user demands more and more facilities in their existing services. Just like 5 years before, we had a small phone or a basic phone, which there was no what do you call internet was not there initially. Then later internet has come. Now it has become a smartphone. Then. So again, now we were using 2G, then 3G and 4G. Now we are going for a 5G. So 5G, why we are going on changing? We want to adapt the new technologies, new features. So software is very, very powerful, what you can call that. Yes. So, and there is a lot of demand for software, what you can call that. It's fine. Next, so that is about your power of software. Now what are the challenges in software projects? We will be seeing what are the challenges. Yes. So now, as you see, you may be seeing now, for example, there are so many problems happening in your mobile phones or through your Facebooks or your Twitter or Instagram. So many problems have been created through this software. So as the software has made a life easier, at the same time, it has made a life riskier also. That we are uploading all your Facebook images, all your photos wherever we are going. Yes, we suppose we are living out of station today and we are in somewhere in other part of the country and we are uploading the images in the Facebook and it is being public, it's in the public domain and everybody will be watching it, and what you call this will lead to what you can call somebody may that the others the person may know that you are not there in your house, so they may what you call make a theft in your house. So these are the things happening there. Yes, so as the computer, what you call the software has made the life easier, it also has made it riskier also. And the same way your mobile through your banking transactions, what you're doing online transactions. So there are so many what you call hackers are available who are hacking your data, there, personal information, your account number, your credit card number, your debit account number, and they're exploiting what you call this online technology and accessing your account without knowing that. So these are the risks involved there. So we are using online technology at the same time. There are so many risks involved in that. Yes, yes. So these are the challenges. What are the challenges in the software? We're going to discuss it here. Then. The complexity of software projects is increasing. Organizations with operations in different locations in different countries need sophisticated software to manage their operations. As user demand more facilities for their existing services, yes, exist existing services, manpower As user demand more facilities for the existing services, software becomes more complex. See, the software what we want to have more features. The smartphone with more features, more speed. We ask like we want. So we want to do the fast calculations. We don't have patience. So we want higher speed phone, a large storage capacity, yes, and a phone with a large RAM, and so on that. So these are all the challenges what the industry has to face. Then also, as crime continues to increase, software now needs to provide good security features. See, because of that, one of the security features provides for banking transaction OTP, one-time password. So that is valid for 5 to 10 minutes. We need to enter the OTP. That is one way of providing security. So this is how it is being possible there. So to avoid the crimes, so these are all the challenges that the software has to face. So it is providing a lot of services, no doubt, but in additional, it has to but these are the challenges what the software has to face it here. So security has to provide it for mobile phone software, banking software, and e-commerce portals, online transactions, your banking, your phones. We are using phone for everything. We are using phone. Maybe you're chatting or banking or mails, whatever it is. Your entire all your transactions are available in the phone. Then yes. So your phone, there should be security for a phone. What you can call that. Fine. Next, developing mission critical software for a number of applications such as biomedical equipment, nuclear plants, transportation control system, which demand zero defect software is highly challenging. See, in your missile technology or nuclear plants, so these are very, very critical applications there. A small mistake, even a 0.0001 percentage mistake can make a big blunder. So we'll be seeing that the next examples are there. We'll see what is that, how the small blunders were there. We'll see that later. Yes. So in all these applications like biomedical equipment nowadays, for example, you're in corona pandemic, you can call that a small mistake. Your oxygen level, if it is for example the minimum level will be 90. Suppose instead of 90, if it is showing 80, the equipment, then what happened? You'll be what do you call? You'll be in panic. My oxygen level has come down. So it's very, very important. Nuclear plants, transportation, yes, transportation control system. Like for example, your railway or your flights. See, a small mistake can make a big blunder. What do you call that? A small particular flight is landing and there's a takeoff. A small mistake may collide your flights or trains. Yes, and all these applications required zero defect, no errors at all. A small mistake also should not be a zero defect software. So this is very, very important. All these applications are very, very critical applications, though these require zero defect software. Yes. So these are the challenges what the software has to face it. Fine. Then other challenges are there. Then there is large demand for software professionals, but there is shortage of quality professionals. Their engineers are there, no doubt. Software engineers are there. So many are, plenty are there. But what happened? They are not well qualified or they were not well trained, what you can call them. So what happened? Some employees jump from one organization to another during middle of the project. So project completion will get into trouble. So suppose one company is paying 50,000, for example, now. Now at the same time, another offer comes to him. The other company will pay him 1 lakh. What this software engineer will do? He will leave this company in between and go to the next company. So due to this, what happens? The project will get stuck up there. So you cannot able to complete the project. So manpower attribute is one of the main challenges to be handled in the software organization. So manpower, see, as I told you, one company is paying 50,000 now, other company offers me 1 lakh. So what happens? Yes. So what happens? Just a minute. Fine. Yes. Yes. So manpower is one of the main challenges in the to be handled in the software industry. Yes, fine. Then there is huge pressure on development organization to deliver software products. Due to time pressure, the developed software contains bugs. See, as I told you, the software, as you discussed in software development life cycle, always the project will be given some time there. You can call time duration, maybe like 6 months. So within 6 months, you need to develop the project, but you are unable to complete it. So what happened? The testing will be given at the end, what you call. So during this, So actually for 5 months you may take what you can call a lot of time. Yes, and at the end you'll identify that your projects are going to complete. You are reaching you're unable to reach the deadline. So a short time will be given to what you can call the testing team there. Due to this, what happened? So they try to complete the testing, but as the time is very less, so there may be bugs in the software. Is it clear? That is one of the reasons. That's what happening there in the industry. So they do not do testing properly. So a small time is given, and there's a lot of pressure for them. Is it clear? Because of that, what you can they may not be able to do proper testing there. Then what are the challenges in the software development? So developing zero defect software. We want the software without any bugs. Then meeting time constraints, as you told. So the time required 3 months or 6 months. Then increased complexity of the projects, and there are shortage of skilled people. What we call it. Yes, fine. So these are the challenges in the software. We can call it. It's fine. Next is we are discussing some software fiascos, what you call. So there were some failures were there. These are software fiascos is nothing but the failures which have occurred already. These are all real-time projects which have occurred there. Yes, first one. Ariane 5 is one of the project. Yes, what is that? We'll see. On June 4, 1996, European Space Agency, they launched the Ariane 5 satellite launch vehicle. Exactly after 40 seconds after liftoff, at an altitude of 3,700 meters, the launcher exploded. See, they might have taken so many years to develop this satellite, and just after launching of 40 seconds, it got exploded. See, they might have taken years of time there, 5 years or 6 years, and so on, whatever it is. Is it clear? So it has gone, what do you call it, exploded. So many, what happened? What is the reason for failure? In one of the embedded system, a software exception caused the problem. A 64-bit floating point number was to be converted into 16-bit signed integer value. During one calculation, the converted integer value was more than the value that can be represented by a signed integer. This caused an operand error. The software exception was badly handled. The specification of the exception handling routine was to indicate the failure on the data bus, to store the context in the EEPROM, and to shut down the processor. The processor was shut down, and this created problem. The failure occurred due to lack of testing and flaw in the software design. See, a small mistake. What happened? So the 64-bit integer was converted into 16-bit signed integer. So a small error was ignored. Due to this, what happened? Your entire launch satellite vehicle was exploded. See, conversion. So why this was due to what you can call testing was not done properly. That was the first failure, major failure. We call Ariane 5 there. Next second failure of the project. Patriot missile. So this was the Gulf War, which happened in the year 1991. An Iraqi Scud missile hit an American army barrack, killing many soldiers there. An American Patriot missile could not track and intercept the Scud missile. The reason was a software bug in the Patriot missile, what you call. A missile was fired from Iraq, yes, and that missile attacked the American. So, but they could not identify. Why? What is the reason there? Whenever the tracking system of the Patriot was switched on, it measured the elapsed time from an internal clock in tenths of a second. This value was multiplied by 10 to get the time in second. The calculation was performed using 24-bit fixed integer point. Yes, they use fixed point register. Hence, the value of 1/10 of a second stored in the register was truncated to 24 bits. When the value is truncated, an error is introduced, and this error accumulated over a period of time. So what they did, they truncate the number. It was a 24 bits. Suppose if it was larger number of bits, then the error would not have been. So when they truncated, so due to truncation of the number of bits, error was occurred there. So because of this, there was a error of 0.34 second there. The Patriot missile was switched on for about 100 hours, and so the accumulated error was 0.34 seconds. Scud traveled with the speed of 1,676 meters per second, and as a result, the Patriot could not intercept the Scud missile. So due to this, again, that is another failure. Due to the truncation also, there was a failure. This is another failure what was happened. So testing is very, very important, what you can call that, because of that. Next failure, third one. No, we only two are there. So with this, what do you call in this in this session the two failures are there that the what we discussed. One is Arine 5 and Patriot missile failure is there. So there are three others also are there, that is Mars Pathfinder we're having, then we're having what you call the Great Bank Robbery and other FBI virtual case. Three more what you call failures are there. We shall discuss that in the next classes there. Some just a brief questions are there. What is this? State true or false. Software has now become the lifeline of system. Yes, the answer is already available there. Just it's true. Then the challenges in the software development are all the above. What do you discuss? Developing zero defect software, meeting time constraints, shortage of skilled people, and all of the above is fine. Software fiascos are defined as software failure, software flaw, software fault, and all the above. Yes, fine. Then again, true or false, software failure occurred due to lack of testing and flaw in the software design order. So it is true. Yes. The main advantages of multiple bus or single bus is reduction in the number of cycles of execution. So what it is going to do, it is going to increase in size of registers, better connectivity, and none of these. The answer is increase in the size of registers. No, these are some. Yes, fine. It's fine. Those are not related to the particular topic. You can call the questions were. Some other questions were there. Yes, fine. With this, we'll wind up the session there. Any doubts if you have got now? Did you follow this session?
Yes, sir.
So we shall stop at this point. Just I'll stop recording here. Just a minute.